This is the last video lesson, and it's on quadrilaterals. So four-sided polygons. We talked about triangles, talked about regular polygons, and now we're going to look at quadrilaterals. So the basic definition of a quadrilateral is it has to have four sides. Could look like anything. As an example here, definitely not a square, rectangle, nothing. It's just kind of weird looking boomerang-y type shape. As long as it has four sides, they're straight sides, it's closed, it's a simple curve, etc., we can call it a quadrilateral. There's a special type of quadrilateral called a parallelogram. So four sides, just like the other quadrilateral, except this one has some extra stipulation on it to be called a parallelogram. The opposite sides, the sides that are opposite each other, are parallel to each other. And we talked about parallel, or you looked at parallel, I guess, in the vocabulary terms. And the other set of opposite sides are parallel. Both sets of opposite sides do need to be parallel to each other for this to be called a parallelogram. So this shape has two names, parallelogram and quadrilateral. Moving forward, here we go. A couple more. A rectangle. A rectangle is a special type of parallelogram. So not only are the opposite sides parallel, and not only does it have four sides, which makes it a special type of quadrilateral, but one angle has to be a right angle. We will not prove this here. We'll do this in a different chapter, I think in chapter 12. But if one angle is a right angle, it has to work out, it always will work out, that the other three angles are right angles as well. So as long as it has one right angle with a right angle, this parallelogram can also be called a rectangle. So it's a parallelogram, has a right angle, we can also call it a rectangle. And it's a quadrilateral. So this shape has three names. A rhombus, again, is a special type of parallelogram. There's no right angle in a rhombus, so it is not a rectangle. We can't call this a rectangle. But not only are the opposite sides parallel, in a rhombus, all the sides are congruent to each other. They're all the same. They're all equal in measure. So if we measure all four sides, they're the same length. So the four sides are congruent and the opposite sides are parallel. So this is a rhombus, this is a parallelogram, and it's a quadrilateral. Doesn't have a right angle, so we can't call it a rectangle. Bottom one here, a square. Again, a square is a special type of parallelogram. The opposite sides are parallel. It's also a special type of rectangle because the angle here is a right angle. And it's a special type of rhombus because all the sides are congruent. So it's got lots of names. It is a square, it is a rhombus, it is a rectangle, it is a parallelogram, and it's a quadrilateral. This particular shape has all sorts of names that we can call it, and it's a very special type of rectangle because not only is there a right angle, but there are four congruent sides. Not only is it a rhombus because all the sides are the same, it's a special type of rhombus because it has a right angle. Moving away from the parallelograms, we've got trapezoid and isosceles trapezoid. So a trapezoid is not a parallelogram. It is a quadrilateral. It's got four sides, but it is not a parallelogram. Both sets of opposite sides are not parallel. This set here going side to side, these two are not parallel to each other, but the top and bottom in this case, doesn't have to be top and bottom. If you turn the shape sideways, then it'd be the side, not the top and bottom. But at least one pair of opposite sides are parallel. Sorry, not at least one, exactly one pair. Exactly one pair of opposite sides are parallel, and the other side are not parallel. That makes it a trapezoid. This is kind of our picture of a trapezoid. When somebody says, think about a trapezoid, this is usually what we picture is this isosceles trapezoid. Again, because we like to have things to be equal. So an isosceles trapezoid has equal sides here that are not that are not parallel. So the sides that are not parallel are congruent. And it says the base angles are congruent. The base angles could be the bottom angles here. You could think about it as the bottom angles. If you spun this shape around, so it looked more like this one, you could also say these angles up here are congruent. And so the base angles is a little bit of a misnomer because it doesn't have to be on the bottom. It could be either one. So these two angles up on top are also considered the base angles, and they would be congruent in an isosceles trapezoid. And these two angles are congruent in an isosceles trapezoid. This line here could be straight up and down. We could have a 90-degree angle down here, and it would still be a trapezoid because this would still have to be at an angle right there. It would still have to be at an acute angle down here. And we would have one set of parallel sides. So that trapezoid doesn't have to look like the Pizza Hut sign. It could be a straight up and down line here. So that's a trapezoid. There's one more type of quadrilateral I'm going to talk about, but before I get there, I want to give you kind of a visual idea of how all these, almost like a flow chart, of how all these different quadrilaterals connect to each other. So a quadrilateral is a polygon. So it's a special type of polygon. And within that name of quadrilateral, we could call it a parallelogram. A parallelogram, as I said, is a special type of quadrilateral where the opposite sides are parallel. Underneath parallelogram, there's a special type of parallelogram that we can call a rectangle. That's really what I have a picture of here. So it's a parallelogram with that right angle. It's a special type of parallelogram. So this picture, this rectangle that I have here that I'm tracing, is a rectangle, and it's a parallelogram, and it's a quadrilateral. So we can kind of follow this flow chart up and say, well, that's how many names we can give it under this quadrilateral grouping. A rhombus, again, has three names: rhombus, parallelogram, quadrilateral. We can follow that flow chart up to see what names apply to it. Rectangle does not apply to the rhombus. A square, same idea. Square has lots of names. It has square, rhombus, parallelogram, square, rectangle, I already said parallelogram, and quadrilateral. So it's got 5 names: square, rhombus, parallelogram, rectangle, and quadrilateral. I mentioned the trapezoid. Trapezoid is a little bit different. It's not a parallelogram. And an isosceles trapezoid is a very special type of trapezoid where the base angles are congruent and the sides are congruent. Kind of like in an isosceles triangle, 2 sides are congruent in an isosceles trapezoid. I mentioned there was going to be one more. So there's this other type of quadrilateral which sort of plays into this flowchart, but not really. It's called a kite. And it's not a trapezoid, and it's not a parallelogram. I'm going to show you a picture here in a minute. However, a kite is a rhombus. It's this weird little caveat where it's technically a rhombus. It's definitely not a square. And so the kite has a hard time falling into this flow chart. It doesn't quite work out with everything else. It's this weird black sheep of the family that doesn't get invited to the family picnic. The kite is a quadrilateral. It's not a trapezoid. It's not a parallelogram. And it's sort of a rhombus. I'll show you what I mean. This is a kite. So a kite is a quadrilateral. The adjacent sides, the sides right next to each other here, are congruent. And the other 2 sides are also congruent. So as you can see in this example, it's not necessarily a parallelogram. These 2 sides are not parallel. These opposite sides are not parallel. However, if I go back to my picture of, here we go, a rhombus, these 2 adjacent sides are congruent, and the other 2 sides are also congruent. So a rhombus is technically a kite, but it doesn't match in with this flowchart very well. It's kind of this weird little offshoot, which is why I have it up over here. So while this flowchart works really well for deciding that a square is a rectangle and a rectangle is a parallelogram and a parallelogram is a quadrilateral, the kite doesn't quite fit in with that. But it is a type of quadrilateral. It has its own definition. And we do draw these. I mean, we fly them. So 2 adjacent sides are congruent, and the other 2 sides are congruent. And that's a kite. And what you'll be asked on a test is to identify, here's a shape, here's a picture, what names can you give it? List all the names that you could possibly give that shape. So if you see a picture of a rectangle, I would expect to see the name rectangle, parallelogram, and quadrilateral. It's got 3 names that we can give it within this family here. This idea of a flowchart and going up the flow chart and trying to decide how things are interconnected does play out outside of math class. One example is any kind of like a food tree like this. I don't know if I'm saying that right. I'm not a science teacher, but I think that's the right term. Is the grasshopper eats the plants. The grasshopper is eaten by the scorpion. The scorpion is then eaten by the fox. So the plant is eaten by everything in this line. The plant, whatever's inside the plant, whatever pesticide is in the plant, is going to make its way into the fox. And it goes this way too. So we could have more than one arrow going into the fox. The fox is going to get the pesticide from the ground squirrel and the scorpion. The golden eagle is going to get from. So you can see how this kind of working up the flow chart does play out in other areas too. And that concept then is important, and it's helpful to see the same idea, the same concept in multiple disciplines. In science, in math, in social studies, you might see it. And so it does play out, and it's very helpful to have that visual flow chart and try and hook in to different students at different times whenever we can in multiple ways. Another place, this is going back to math now, I know, but another place where we see the same idea is in classifying numbers. Natural numbers, we talked about this in numbers and number systems. Natural numbers are a special type of whole number, which is a special type of integer, because integers are the positive whole numbers, the natural numbers, and their opposites. Integers are a special type of rational number, and so on. So you can see there's different types of numbers, and they all kind of work their way up. And technically, this isn't it. There are more types of numbers. There are algebraic numbers and transcendental numbers. So this web gets bigger, but for now, this is a fine example of numbers we've already talked about, and how an integer is also a rational number, is also a real number. And so this concept, this flow chart, is helpful to see in multiple contexts, and it does show up outside of geometry. All right, watch the video on how to do the assignment for this, and we'll see you in class.